Javier, please share your screen.
Buenos días o buenas tardes. Un segundo.
Hola.
¿Me escucha?
Sí, claro.
Ya, voy a tratar de compartir. By the way, English, Spanish, or Portuguese?
English, I think.
Okay. No, just in case, because it's in São Paulo.
Yeah.
Sorry that it's not perfect, but I will start. Okay, may I?
You can start now, yes.
Okay, thanks, Jorge. I am on behalf of the LA-CoNGA physics community, that this is a part of the Erasmus Plus European project. Yeah. It's an open science education collaboration between Latin America and Europe for high energy physics, but also for complex physics. Sorry, the system is not working very well. Yeah. Okay, this scientific collaboration is between some institutions from Europe, yeah, France and Germany, and Latin countries like Venezuela, Colombia, Ecuador, and Peru. Sorry, the problem. Yeah. You know that in high energy physics collaboration from more than half a century, we were international collaboration from different countries. Yeah. And we work globally, distributed collaboration, multidisciplinary. But not only that, yeah. We have a special emphasis in not only the theoretical part, but also the computational, the data analysis part, and also the instrumentation with detector. This very high skill in different directions is very important not only for higher physics, but in different applications, yeah, like physical, medical, nuclear, and so on. Yeah, the idea is to use imitate the higher physics collaboration for advanced physics education, like a master program. We organize a network where data, software, tool, research facility, teaching information is all shared virtually and presentially is possible. Well, the importance is the internationalization is the accessibility. Yeah, I put emphasis in this part because it's my institution in Peru, but also in Ecuador and Venezuela and so on. Each institution, each group may not have all the resource and staff facility. Of course, we don't have, no, in my institution. We know some special part, for example, my specialty is data analysis in high energy physics, but the instrumentation, I only know very little, the theoretical part also know, but know as Jorge, for example. We can share resource, and this is very important for all of us. Yeah, this is more important part of this program, this project. Well, I don't need to have so much emphasis in the high energy cosmology and astroparticle physics community. Cameron a lot in America, in Latin America. For example, Peru, el LAPP. I never know how to pronounce Latin America Strategic Forum for Research Infrastructure. the Helen and LA-CoNGA now and so on. Speaking about the LA-CoNGA, you have the link here. We were in 8 institutions from these 4 countries. From Venezuela, both Simón Bolívar, the Central, from Colombia, Nariño y Santander, en Ecuador, Chao y la University of Quito, en Perú, San Marcos University and National Engineering University. But not only university, we have other scientific partners and industrial partners. For university, well, I put the emphasis here. Some are national or federal universities, like in Brazil you can call. Some are private universities, but this is a fair initiative between this institution, but also 3 institutions for Europe. Université de Paris, is the leader of this project. Dresden and Toulouse as well. We have scientific partners like CNRS, CERN, DESI, ICTP, Reclara, and so on, and other industrial partners like CAEN, Database Access, Frontier, so that's important for us, that the advanced program for the student, for example, a master in physics, has contact not only with the academic, but also with the industrial part. We started in January 2020. We had a 1 year of specialization that fulfilled the Bologna Declaration, but I put emphasis with homologation system, of course, between the participant university as a program. What that mean? That each of our university, like my university, has a master program in physics. They have some requirements from course and so on. And we put this LA-CoNGA physics course and specialization inside our master program. Then the student has to be in a master program from any of our institution, universities in Latin America. And to put in this LA-CoNGA physics program to fulfill the course of the LA-CoNGA inside our master program. Very interesting. The methodology and platform, we use an e-learning open access platform. For example, we use some Mattermost, Jupyter, GitLab, Zoom, Zenodo, our next project. And we are also putting some experiment laboratory with Wi-Fi internet connection to make access from different countries for the student and the professors. No? The thematic series, of course, this started with the initiative with the example of the high energy physics community. Yeah, we put in theoretical fundamentals, yeah, and experimentation, yeah, instrumentation, a strong international collaboration, high knowledge transfer. That's important. But we understand that this is important not only for high efficiency, but many of the knowledge and the practice we can share with the other areas like complex system, yeah, for supercomputing, supercomputing, or weather, and so on, that are very important, that use a lot of statistics and data analysis like we use in high energy physics. The implementation, yeah, we started with 3 blocks, yeah, in the year. One block, introductory block, yeah, is to teach the fundamental parts of the theoretical physics, also the particle physics and complex system, instrumentation detector, and data science for data analysis, collection, and so on. We had a second block, yeah, for more advanced course, like advanced particle physics and complex physics. We use, we left the student to decide in which line they want to specialize, for example, particle physics or complex physics. That they can choose. But these 3 line courses, everybody has to learn. This part, they can choose one course in advanced particle physics or advanced complex system. Después, we have advanced art and science for the 2 groups. Also, we put a hackathon and citizen science. Yeah, we will use. And so, the last block is inclusion. We will have some stays in Latin American laboratories or Europe, or even the industry in Latin America, but they need to spend some time working with the academic in research, yeah. Also with the industry, to know how they can apply all this academic knowledge in other areas. Yeah. This is almost the 1 year. I say all this is included inside our master program for each institution. We also, I may mention, but I may put emphasis here, in the remote lab, yeah, also the bibliography, the videos, control that taking yeah, by internet, remote detector instrument, yeah. The communication, we work with instruments from National Instruments and CAE, yeah. That's the idea, to put in different small laboratories in each institution. We will have access from the rest of the institutions to can manage from this detector experiment. Also, as part of this program, we put several seminars also for the diffusion at the beginning. It was in the last, in the last year started, and also continue all this year. Yeah. Every week or every 2 weeks, we put many seminars from different parts. Even here we had Fernando Quevedo when he talked about the standard model, and Stephen Waldwell after his thesis. Yeah. And many topics in high energy physics and in complex systems as well. Yeah. And also some connection with the industry. Yeah. Well, how is going on until now? almost 30 instructors from different Latin countries and Europe. More than 50 students from our 4 countries, more than 100 classes. The first semester was in all the students started the course in particle physics and complex system, instrumentation and detector, and data analysis and statistics. And the second semester started statistical mechanics, astroparticle, even medical physics also as well. Yeah, they can see the application in other areas. That's very, very, very important for us. Well, sorry, I promised to my group, yeah, but I forgot to do it to pass this in English. But okay, you understand that it's an international collaboration, interconnected community, remote presentiality, social impact, open access. Yeah, all the politics we just use for our project. Yeah, if we expect to help the people. Well, thanks a lot. Yeah, we are just a few of us are here, but you can see in the website most of our team. Yeah. Okay, I will finish here with the sense. Yeah. Gracias. Obrigado.
Thank you, Javier. So I think we can ask questions after for the 2 talks that because they're related, right? The next talk is related to this one.
Yeah. It's more specialized, but yes, it's related.
Yeah. If so, maybe we can ask questions for both talks at the end of the second talk. Is okay? Or you prefer now to ask questions?
No. Sorry, because I had other problem. I prefer the question right now for me.
Oh yeah. Okay. No. Fine.
No,
so there are some questions now about the Javier talk.
I think that Arturo want to say something, or
Arturo?
No, just to say that was fine to be both, but no, because I am the next.
Yeah.
Sorry, because I am in the university council. I need to receive the credentials now in this moment. Yeah, and after I finish, I return here, but just in case I spend much more time.
Okay. So okay, I have a question actually. How do you work? How the people enter the program as a regular student in each university and then can specialize in this line? How the thing works?
It was difficult. You know, the COVID pandemic was terrible, but our project, I think, was one of that the best working in this kind because our project was prepared for this international collaboration, this semi-presential. Yeah, we were prepared for a semi-presential activities, not all the full remote activities, but we were more prepared at other programs. Yeah, then it was difficult, but I think it was very good for the students. For us, it was a new experience because we know some topics, we are researching some topics, but we have contact with many other researchers in different topics. That was fantastic. Yeah.
Yes, but how the student can enter the program?
Well, they student entering in our master program for our my institution in my case, and for other institutions, other universities. Inside the master program, we say all the courses of LA-CoNGA physics will valid for the master program. Okay, yeah, you need to fulfill, and you enter in the LA-CoNGA physics program and also in our master program. Yeah, LA-CoNGA physics course are part of our master program.
Okay, yeah, all right. What kind of facilities the students have? For instance, they can travel abroad or something like this, some kind of...
okay, no. You know that this 2 years was a full pandemic.
No, but in the future, I mean, in the future when we solve the problem of the pandemic.
No, the idea, no, the idea is that they spend some stays in different laboratories from different discs. Yeah. Some of the best students will pass some researches in other countries. For now, this stay is still remote. Yeah, we have student contact with people from Mexico, France, Colombia, and so on. Yeah, it's a remote, unfortunately. Even that in December we will have some small event that we will join all the student research for the first time in 2 years. Yeah, but in next year, yes, we will have the student more contact con students. They will participate in some events, congress, and so on. That's the idea.
Okay, thanks, Javier. Are there some more questions?
Okay.
Yes, there is a question.
Okay.
If not, maybe we can ask question at the end of the next talk.
Sí, and Arturo can answer the question also for my talk, so from his talk. Yeah, we work together. Okay, no problem. Yeah, okay. I need to leave. Sorry, because Arturo can answer.
Okay, so let us thank Javier again. Thank you for your presentation. Thank you, Javier. Okay, Arturo, then please share your screen. There was a question by Rogerio, or not? It's okay, fine. So Arturo, please share your screen.
Hello, can you hear me? And here I see my screen, please.
Yes, it's fine.
Perfect. So yes, thank you for the opportunity. This topic is a little bit different from all the rest. The idea was try to summarize a series of projects and a series of trends in what is open science in higher energy physics, but you can extrapolate this very easy to another field. So because I don't have so much time, I will give you more a teasing of several proceedings that we have regarding to this way to do open science. So let's say in regarding to what I mean, open science here will be always in the context of computational infrastructure, so or digital objects. Let's say I am not talking about, or better say I am talking about data, software, blueprints, this kind of thing that you can save basically in a computer, just to clarify this part. Also, some of the cases here is that in high energy physics, like in many other lab collaborations, the tendency is to have also dedicated programs to what is called knowledge transfer across the members in the collaboration. Usually also this happens that these collaborations tend to design the experimental system, including those on information and communication technology. This is the part that I will be talking more about. But this kind of design is quite close to what is the industry standard. And that's something that the idea is to profit for the different development that happens in the outside world, so outside the collaboration. One of these tendencies is software as a service and infrastructure as a service that are basically reshaping this kind of how the way that the people is handling these digital objects, once again, independently of the science that you are doing. And I will at the end mention an example that we do dedicated in Atlas Open Data in this regard, how we can profit of this software as a service, infrastructure as a service to provide infrastructure for the education, like the program that Javier just mentioned before, and others. So regarding to knowledge transfer, again, just to make the case, we are aware that very large collaboration, not only CERN, but also Space Agency, for example, they have dedicated programs to transmit this data, these protocols, these techniques, this technology across the different members of this institution, but also outside to things like, again, education, outreach, but also industry and other partners that need to exchange this kind of information. So this is, again, not new in this very large collaboration. In the case of Atlas, that's, and again, I bring it just as an example. That's also the case. We have this kind of collaboration that started from the education, so something outreach, the general public, going more into deep in education and the level of the university and helping to the curriculum, for example, of what is happening regarding to teaching physics, to teaching analysis of data. And also in terms of how we do this knowledge transfer of the technology that we also bring back into the collaboration. And this is not only because it's the responsibility of the collaborations, but it's also a question of survival, at least in my point of view, in the sense that you have a 40 years experiment and you need constant fluid of people with all this knowledge in order to keep this experiment and this collaboration running. So just a quick reminder, Atlas is at CERN, just to give you an example. CERN is here in the border between Switzerland and France. The transfer of knowledge used to happen between the collaborators. So the members institution, the members, again, Atlas is just an example, but you can put here any LAC experiment or other kind of large experiment, cosmology experiment, for example, big telescopes, where you need to teach to your members how to do this kind of analysis of data, for example, how the protocols are done. And this is usually done using open access resources, because as you can imagine, not all the members have the same access to resources, to computational resources, to license. So the only way that this is done is through open source and open access technology. But it's also this tendency, again, to distribute this knowledge to everybody else. So exchange with the outside world, let's say with the outside the collaboration, this kind of knowledge through the repositories, through different conferences, to papers, to collaboration again with the industry in order to exchange this knowledge. So this is what I am mainly talking about here. And again, there is technologies, for example, in the case of software, everybody, I guess, here know what is Git or Git. But just to give an example of the way that this kind of collaboration are doing to preserve the knowledge, but also to find new human resources to be part of the collaboration, to be part of the science, is essentially using open access, open source projects. And it's also happening in the industry. So we will talk a little bit more about this. So when the knowledge transfer is going across the board, what I mean is not only inside the collaboration, but also outside, and it's also bidirectional. So that means that we are also getting a lot of knowledge from the outside world. From if you just start to see this collaboration from, let's say, for a certain distance, you will realize that they look more or less like a technology company also. So there is a lot of things that are very similar in the way that it's organized, but also in the technology. So again, just a few aspects of how this knowledge transfer is happening. And this is why it was great that Javier was before me, because there is, in terms of the education and the different programs, for example, I have the opportunity to participate, like, again, Atlas Open Data, or in LA-CoNGA, or in Escape here in Europe. Essentially, what we have is a part of this knowledge transfer, a part of this open science that is happening is through the education. So from the PhD students, the new candidate PhD student that come to, for example, Atlas and do qualification tasks, or are trained on how to analyze the data, how to open the software that we are using. Yes, of course, these kind of students come with knowledge about the physics that they are studying, but some of these protocols they need to learn once they are inside. So this a lot of this training, inside training, but also students that happen to come for a short period of time. That's the way also that you start to involve very young students, but with short project, we call it summer student, but obviously it's not summer everywhere. So just an idea to say that for a short amount of time where they are engaged with the scientists, and also university student for a longer term project, again, like a university courses, or participation in those courses, better say. But it's not only between the researchers and the students directly, but also researchers and the professor, the teachers, the instructors that have obviously a more massive impact because they have 40, 50 students. So there is a lot of interaction also with them in terms of how to use the tools that this kind of collaboration provided to the outside world to do this kind of training. In terms of the collaboration, this is something that is very well known for you in terms of there is a way to do it to conference, like things that we are doing right now. We tend to use it also in person and exchange knowledge there. The way that we do in terms of paper, there is a lot of effort, for example, in terms of CERN. Just to give you one example, I insist, is that all the papers that are produced into the CERN experiment are open access. So there have been an effort between in this case, the market that was before there to get access to the papers and the different laboratory in order to get open access to that part. And again, I insist there is a lot of external partners, especially in the technology sector. So this very large collaboration, this very large laboratory tend to be a perfect scenario to test, to stress new technology, new computers, new computer systems, new ways to connect computers. So there is a lot of interest also in the industry to prove that the product that they are building are able to deal with this kind of stress, for example. And finally, for example, in my case, but it's very, very common, collaboration between funding projects or international funding projects, in this case, European Union funding projects that also change this kind of technology between them. So all this together at the end will give you a sense of software, blueprints, patents, and publications about it. So again, I mentioned this, sorry, because I have a lot of material here, but there is especially a collaboration between the industry and the laboratories in terms of the communication technologies and common infrastructure. And I leave a document here about this that talk a little bit deeper. But the whole point of this is just to mention that more and more these different science are starting to develop programs that go transfer to the experiment. So the idea is to find common tools for how you compute, how you store data, how you deal with the data, how you read it, how you transmit the software that is used as a framework to develop your analysis and your pipelines, for example. So something that they have been more common seen in this way, where you have different experiments and each of them will have their way to publicate, to get DOIs and access and repositories, have been more going into common service. And this is the more usual thing. So common service there, like for example, Javier mentioned that there is a Zenodo, that is just one example of many, of how the people start to store data in a generic platform, science independent in some sense. But it's also important in the other part, that is where a common service in terms of computing, storage, software, the monitoring, and the way that you keep all this information together. So here is where there is a lot of work happening right now, and how to develop, how to build, and how to manage this kind of common services across experiment by different institutions, so maximize the impact that all these resources have. So again, there is particular points that have been written here that we can come back if it's necessary. And obviously, if you are interested, the slides are there, and we can talk later. But in terms also how the computing systems, the storage, the bookkeeping, and the software have been relying more and more in a standard of the industry to do all this job. And this is not only because, again, it's good to have a standard because, again, it's easier to transmit that knowledge across the world, once again, but because also the people can move between fields. People is coming from the industry into science, and people is going from science to industry. And this is very important for the management of all these very large collaborations. So I will just finish, and I have just need 2 minutes more to say in the case of the Atlas, and I have also a DOI here of a proceeding that we published a few months ago, and how we are dealing, for example, in creating this kind of transfer technology, or this transfer knowledge in terms of how to do analyze data. And in the case of Atlas Open Data, we do this in terms of education and training, but it's very easy to extrapolate also for analysis of data in science, in pure science. So the tendency have been always, again, in the picture, just to exemplify the classroom, the way that we tend to have software that is installed in individual computers. We have been working a lot at CERN to try to make this recipes, if I can call it this, these recipes to install computer infrastructure very easy. So much easier than what is now. So the idea is essentially that you can come to the website right now and download some of the recipe of how you can deploy an entire Jupyter Hub in a cloud computing in a couple of hours. So we have been developed this idea in order to allow smaller institutions, a small infrastructure, to still have a very similar infrastructure of those that are very large collaboration. So the idea at the end, in this particular example, just to give you an idea, is that we are producing containers. So are these software environment that we save for the people, and the people can download in the very similar way that we have done, for example, with virtual machines many years before. But we also have this recipe on how you can build your own Jupyter Hubs, for example, your computer infrastructure in different cloud providers. For example, right now there is a tendency for several institutions to rent private cloud computing. So we are profit of this idea to say, okay, now we can provide you with some recipes so you can have a very similar infrastructure to what you have in the lab very quickly. And of course, there is several flavors for that. The idea of all this is that we are trying to approach, let's say, asymptotically, I would say this in this case, to a single click solution where people can install this kind of infrastructure. This is not to say like we are selling you these recipes itself, but I mean to say with all this, and this last example is that the tendency has been to use standards more and more across the different common services in the experiment. And that allows us to use these very same protocols to be very fast in way to create infrastructure, not only for very large experiment, but also for very, for modest and more smaller institution and academic research, for example, like is happening is the case in our region. And with this, I finish. Again, the idea of this was a selection of common paths of how these standard services across different experiments are, in fact, boosting a lot the way that the high energy physics is done, but high energy physics analysis, that analysis is performed. And the very same principle are put into action for the knowledge transfer in the educational programs like the one that was presented just before. And at least in my opinion, none of this will be achievable without open access. And that is my presentation.
Thank you, Arturo. Thank you for your nice talk. There are some questions. Rogerio?
So Arturo, thank you for the talk. Yeah, hi. I just want to ask the following. So we're, as you know, we're thinking about within LASP, we're thinking about the possibility of having some computational infrastructure for services, and some infrastructure for the community.
Yes.
And one of the ideas, of course, is to have a kind of a platform that can have all these tools that you're mentioning for open science. Do you think that's something that's useful for the community here in the region?
Very much, yes. Very much, yes. As we were exploring 2 years ago with the effort, we have a lot of knowledge on how to do this, and it's very generic. This is why we have a tendency to learn Git, and this is just an example. But what I mean to try to reply is that this knowledge is something that the region have. We know it, and we also know that we have infrastructure. Again, when you compare to very large laboratories, okay, we are quite small, but it's still something very big. So university has computer infrastructure, and I think the approach here will be more how we can profit what you have already and make it not only generic, but also, sorry, I was looking this word for a long time, like, again, I insist in these industrial protocols are very useful because that ensure a long time, lifetime, of this project. Yes. So that's something that I really, and this is something that we are putting a lot in ESCAPE, for example, and how do we create an ESCAPE infrastructure that is a program for the European Union to, in this case, not be to use high energy physics as an example, but hopefully sell the idea to other science in the open cloud computing at Europe.
Thank you, Arturo.
Okay, thank you. More questions? Diego?
One important aspect of the open data is to guarantee reproducibility of the results. However, in Atlas, seems to be that the open data is only for educational purposes. There are experiences from other collaboration, maybe from the NASA one, Fermi Lab, and so on, where they also have this kind of philosophy to open the data for research. Do you know if at Atlas there is some plans for something like that?
Yes and yes. I mean, the first yes is respect to other collaboration. You have here Edgar. He's at CMS, and they do a lot of open data for research. So yes, there is other examples already. For example, in the LAC experiment. The second yes is regarding to the Atlas releasing data for scientific purpose. That's also happening. In fact, I just sorry that with the COVID, I don't know when it was last year or before last year, but have been an agreement at CERN that after some periods of embargo, all LAC experiment will start to release data for research. So this is happening. So inside the collaboration, at least in Atlas, we are getting ready for that in terms of which format we will release, because again, we, at least again, myself as a co-management of open data Atlas, have been very important to have formats that are easy, I mean, between the scientific, obviously, environment, but easy to read. So this is something that is now on the design table for how Atlas will do that release that will happen. That's for sure, Diego.
Okay, thank you. More questions? I have a question, Arturo.
Yes.
Suppose I want to use some of the tools there. Let us think it in a concrete way, some computational tools. Which is the simplest way to access the information? There is some kind of a route to get the information, some web page.
So again, for example, let's say the question is, will depends a lot on who is doing it, but just to give you an example, we have the Escape project, and again, I didn't want to bring it explicitly because the presentation was more generic, but we are creating, for example, some web page, yes, exactly what you are saying, where you can access to the open data, the open software of the experiments that are part of the collaboration. So what I wanted to reply to you is that more and more there is a tendency to create this kind of cluster of experiments. That's maybe not the word, but where experiments say, okay, we are putting experiment means a university, so institution, this part of hard disks, this part of computing. So they are sharing it, and now we are creating a common website or a common platform, better say, for the experiment that are part of that collaboration. Now what for example, the European Open Science Cloud is doing is that more and more experiments go inside. So you should be able to come to one place and find hundreds of experiments and know hundreds of websites for one experiment each. So right now, for example, CERN has, in terms of knowledge transfer, there is a website and it's really awesome. I just invite you to visit it. I put it somewhere here, where is an explanation, especially how these resources, especially when you are dealing with things that can be used outside energy physics. That is one of the objectives of this, that you can use, you know, the same software to do markets analysis, stock markets analysis. So it seems like this is happening for real.
All right. And one more question in the same direction. I know that, for instance, the astrophysics or astronomy community also has a lot of information in this sense. There is a plan to integrate that. Is already done. How is the situation?
So again, coming back to the Escape, this is the one I know. There is we are now integrating very large experiments in the cosmology sector, like the CTA and LSST. So what I meant to say is like usually the cosmology have their own very big collaboration. I know there is something called the virtual observatory, where they have a common place, different experiments have been put in data. And now what is the connection, let's say the initial connection between a very large telescope experiment, for example, cosmology experiment, astronomy, and high energy physics have been once again at the end of the day, both are producing petabytes of data and both needs software to read that data and do analysis. So the integration have been more in that level. I don't know if that replies your question, sorry.
Yeah, thanks. Some more questions? If not, well, let us thank Arturo again. Thank you for your talk. Rogerio, now I think we finished the session of the morning session, right?
That's right. Now there is a break.